Thank you, everyone, for showing up this morning on the very last day. Hopefully, you've had a great week. We're here to talk about supporting enterprise applications with production-grade Kubernetes. This is a conversation about the infrastructure, or the Kubernetes, on-demand Kubernetes, as a platform, and not necessarily about the applications themselves. Okay, so hopefully you were expecting that. My name is Tuan Nguyen. I'm a technical marketing engineer for Cisco. I've been with Cisco for 2 years. I was actually a transplant from an acquisition that was Clicker Technologies and is now Cisco CloudCenter. Okay, so we're going to go through a product overview. The product itself is called Cisco Container Platform. You may have heard of it. Heretofore, it will be CCP because I don't want to say the long name, right? So Cisco Container Platform, CCP. We'll go through the product overview. We'll address some of the challenges with a production-grade Kubernetes and how we're solving for those challenges, especially around storage and networking. And then we'll talk a little bit about the hybrid cloud platform that was announced, or you may have heard about this week, and some of the inherent benefits of that reference architecture. Okay, so the premise of Cisco Container Platform is really to provide IT or the enterprise with a production-grade turnkey solution for consuming Kubernetes. Okay, so some of the challenges with Kubernetes is automation, it's consistency, it's integrating it into the entirety of the enterprise ecosystem. And so what we're doing is we're taking code from upstream Kubernetes, right? I'll explain a little bit about that. And we're making it easily deployable, easily consumable, right? And what we're really designing for is a consistent environment for Kubernetes across different clouds. So it could be on-prem, as well as xCloud, whoever the cloud is. I'll talk about the partnership that we have with Google and some of the integrations that we've already built into the platform. But for us, we want to design a platform that is hybrid cloud optimized. And I'll talk about that. We'll talk about the integration between Kubernetes, our version of Kubernetes, and the ecosystem. And then we'll talk about the different deployment models. So today, we have integration into VMware, because really it's the most pervasive of the hypervisors. We spent quite a number of conversations with our customers, and we were counseled and advised that really the need of the hour is for us to deliver a Kubernetes platform on VMs, right? In the future, we'll have integration into OpenStack as well as bare metal workloads. Okay, so one of the ways that we differentiate ourselves is that we make it easy for Kubernetes to integrate into the IaaS, right? So for us, we have best-of-breed products, hardware and software around SDN, core and data center networking, VPN networking, and then, of course, storage with our hyper-converged solution. So we already have an IaaS layer that we've helped our customers to design. And then now what we're putting on top of that is a Kubernetes environment that integrates into the existing IaaS, okay? So a little bit more about that, 100% upstream. We see our opportunity in innovation not so much in modifying, the native API and code of Kubernetes, but the innovation for us is to encompass Kubernetes into the ecosystem that is existing today in the enterprise. And so for us, it'll be easy for us to deliver to you with speed and scale the new versions of CCP whenever Kubernetes version changes, right? So if we're not doing anything with upstream code, it'll be easy for us to deliver it to you faster, right? And then we're also curating that version, which means that we're putting it through a QA cycle and testing and validation and making sure that when it hits your data center, that it's going to be something that, that is consistently dependable across the platform. Okay, so speaking about the integration and about IT consistency, we're covering the day one, day two operations, right? So insofar as we're talking about setup, the deployment of the platform itself is software delivered. It's an OVA. You just import it into vCenter. This is something that is known to most IT operations. And then layering on 3 different options for a CNI, which is a container network interface. We'll go through that a little bit. But from setup to consumption to integration and management, I'll show you how we allow users to self-service and deploy clusters from a management portal. And then also how we add day 2 operations into a catalog into CloudCenter, which is CloudCenter is not a component of CCP, but it is kind of a centralized catalog for multi-cloud deployment. Okay, so CCP itself, Container Platform, did GA in early May. And previous to that, we went through an EAP cycle, which is an early access program. I'm going to explain one of the use cases that we've been highlighting, because it really is the use case that we are solving for. But we did go through an EAP program through 4 or 5 months, and then we have a pretty aggressive roadmap for the remainder of the year. One of which is obviously to integrate into bare metal, and also to onboard more environments like OpenStack. Okay, so from an abstraction layer, what you're getting is a control plane and a data plane, right? So the data plane is the multi-tenancy layer, which really means that different users from different business groups or different development teams can go to the interface of the control plane to deploy their own tenants. Okay, so the tenants are color-coded by blue and green, right? So you can see that there's kind of a separation as far as the default services that run on the tenants, as well as services that run on the control plane, right? So the control plane itself runs Kubernetes. So it's kind of like Kubernetes deploying Kubernetes, right? And below that abstraction layer is just the physical layer, which is the storage, the hypervisor, the networking. So we, very similar to a lot of solutions in the industry, are using Prometheus for monitoring, Kibana as an elk stack, and then we're also using Grafana to visualize some of the performance monitoring for Kubernetes. So architecturally, and both from a logical and a physical perspective, it would look like this, right? So you have HX stands for HyperFlex. So those basically would be your compute nodes. So on your compute nodes, right, if you have a cluster of 3 compute nodes, you would have compute, and then you would have VMs that run the control plane. That would be the blue VMs, right? So the blue VMs obviously would have the same connectivity into, let's say, your storage, your layer 3 network, your core networking, all of those things apply. And then you have the green, which represents the tenant nodes or tenant clusters. Those are also VMs, right? And of course, you can have a one-to-many, meaning many VMs operating on one physical node, which is the HX server, right? And then, of course, what we're showing here is that it's a well-connected stack, whether you're talking about the physical or the virtualized environment, right? And it's self-enclosed. It has access to a 10 to 40 gig bandwidth on the network layer, right? And then upstream, you can you can do underlay or overlay from a Kubernetes cluster point of view. And then, of course, it will integrate into your upstream layer 3 or L3 out gateways. Hopefully that makes sense. So one thing about the PGs, which stands for port group, and VLANs, these are not affixed, right? So these are not static. They're just examples of how things would be connected and how they would be configured across the entire stack. Okay, so integrating into the enterprise requires a few things related to RBAC, right? So we know that our consumers, our developers, are different than our operators. And within the platform, we have a way to give those personas the privilege to do what they need to do, right? So developers usually don't really they're not incentivized to understand how to deliver the service, right? They just want to consume it, which is the Kubernetes side, right? And so IT admins have a different awareness or a different interest. That's to deliver the service levels to the platform so that it can be consistent and it could be highly available, right? So from the point of view of the IT admin or the consumer or the service designer or the DevOps operator or whoever it is, we've got coverage for the day 1, day 2 operations as well as the different personas that are interested in the type of responsibilities. Okay, and then I mentioned that this is deployed through VMware today. So we also chose that because really this is an easy kind of non-friction, seamless way for IT operators today to adopt Kubernetes, right? That's really the strategy behind the integration with VMware. Okay, and then this is really my 3 screens to deploy a Kubernetes story, right? So this is the first screen in creating a cluster, right? These are the different options for the second screen. I'm going to go through a demo. Hopefully I'll have the time for that. And the third screen is basically submission. So what you see here is the ability to name it, to inject a key that is known to the development team, different attributes about VMware, right? So data store, network, port group, the image name, things like that. And then the size of the cluster, right? So one thing about this is that once this is deployed, there are several things that the user can do based on roles to either scale out or scale in this cluster, right? So one of the things that we're adding into the feature set is the ability for the platform to auto-scale itself. Okay, so now we're going to talk about storage, and we're going to address specifically why HyperFlex, the hyper-converged platform that Cisco sells, is important in this relationship with Kubernetes, right? So you probably are aware that within Kubernetes, there's kind of a native driver approach to provisioning PVs or persistent volumes, which means that you can use the basic native driver. It's nothing fancy. It just kind of delivers a volume to the containers. But if you need to deliver a kind of high I/O, persistent volume that also can have some special attributes, then you'd move into the FlexVolume framework, right? So the FlexVolume framework allows manufacturers to create their own specialized plugins for Kubernetes. So that all just described the FlexVolume driver that is specific to the HX platform. Okay, and then I'm gonna go through how it actually works, although I'm not gonna really go through the deep dive, right? This is just, for instance, if you have an ESX server, that's the middle green layer, right? So by default, the abstraction layer of HX allows for NFS data stores to be presented to ESX servers. Okay, now that is just typical shared storage. The VMs that are deployed through CCP, which are the Kubernetes cluster nodes, they can both access the NFS, which is just file storage or file shared volumes, and then they can also via iSCSI, via the IO visor, they can access iSCSI volumes. Now, the important thing about them accessing iSCSI volumes is you are mounting an IO level volume to the container, so that the container can, it's a block level device, right? So the container can actually format that volume and can do special things to it. And the benefit, so the benefit is that on HX, because it is hyperconverged, the blocks of storage get stored onto different servers, right? This is very basic to how HX delivers a storage replication, right? And then, of course, it also automatically replicates. You don't have to do this. The blocks of storage on different nodes, so it creates a redundancy, so that if one node fails, or if one ESX server fails, then Kubernetes will bring up the containers, obviously, and then the containers will also be remapped to their volumes. Okay, so the benefits of doing this with HX and CCP is that you'll be able to apply some data retention policies, data protection policies, and of course, you've got automatic replication. So that's inherent within the platform, and it's something that is native to Kubernetes. You don't have to do anything special. You won't have to install special drivers because of the integration with CCP. A CCP node will automatically have the FlexVolume driver installed every time you deploy the tenant cluster from CCP. Okay, and then from a networking perspective, there are many different options, overlay options, when you talk about Kubernetes. Not all of these options are standardized. Some of them are pervasive across the different clouds, but the unified approach to policy design, policy enforcement is one of the challenges, and certainly a challenge that we are solving with CCP. So there are 3 options for CNIs when you talk about CCP. I'm going to go into the first and the second option. The third option is Calico. That's the pervasive one. You can find it on GKE. You can find it on AKS and EKS also. So it's something that certainly you can do research on your own. The first 2 are the ones that I'll dive deep into. So if you aren't familiar with ACI, ACI is our application-centric infrastructure, which is really just a fancy name for an SDN solution that is both hardware and software. So what I'm describing is, the ability for, let's say, a network administrator or a network operator to design policies that can be enforced by the software or by the hardware, right? So it's designed in software, applied at hardware, and it's effective to east-west communication, right? So north-south, east-west is really where microservices need protection, and ACI is that for both microservices and VM-based deployments. So this is OVS-based. I believe that it's a derivative of Open Daylight. Cisco has had some integration with OVS in the past. This integration, the ACI CNI integration, is a little different, but there are certain steps to do this. If you had a Kubernetes cluster that was not deployed by CCP, so you have the ability to do this on your own if you have Kubernetes and ACI. What CCP is doing is it is automating all of the integration points for you. So, there are a few things that you have to enter into configurations, and then there's, YAML files that you have to bind. The CCP integration will do all of that automatically, and it's beneficial to both the application architects as well as the network administrators, because it's dynamic, right? It automatically protects the pods that are running in the fabric. There are 3 different models of protection. So the default model is a cluster isolation, which means that if you've got a pod subnet, right, all of the pods across the clusters are protected as one entity, right? So in ACI, it's called an EPG, or an endpoint group. The pods would just be considered endpoints, right? And then they would be protected as one singular unit, right, inside the cluster. There's also, if you wanted to annotate the different namespaces, then you could accomplish a namespace isolation, which is not a cluster-wide. Then it would be a kind of separation at the namespace layer, which is pretty unique when you think about it, because things that operate inside of a namespace, or microservices that are running inside of a namespace, can be protected both from each other as far as the workloads, and then from other namespaces, right? So this is treating pods as endpoints on the network fabric. And then, of course, you can go as granular as protecting the deployments themselves. So each deployment, each replica of the deployment would be protected by other services in the deployment. So that's very, very granular. And then ACI, from a visualization construct, makes it easy for network administrators to see what is happening, and to also operate the things that may be a little bit difficult for the application developers to express, right? So we don't expect application developers to understand the network fabric the way that a network administrator would, right? But if there's a way for us to visualize it, which there is, a way for us to visualize the filters and the different contracts and the relationship that we establish in ACI between what we call the consumer and the provider, which is source and destination, then we make it easy for the teams to collaborate and to troubleshoot in one of those firestorms. Okay, so one of the other CNI options, probably something you may have heard of. It's really a platform, a networking platform that is utilized by service providers. It's called Contiv. It's open source, and it's been inside of Cisco for a while. Our service provider customers use it, but it's basically a user space. It's a networking platform that bypasses the kernel, uses the user space, which means that it depends on the driver in order to propagate bandwidth across the different nodes, right? So it's optimized because it's not serial packet processing; it's vector packet processing, and it's something that you can probably get a deeper dive in if you're tied to a Cisco account or a Cisco engineer. It's I think a very intuitive way to deal with container networking. Okay, so we have a plan to really follow the release cycle of Kubernetes itself. So we expect that every major release, right, 1 to 2, 2 to 3, is going to be very aligned to Kubernetes release cycles. We're planning on that to be quarterly. Patching upgrades, which is X.X, is going to be on demand, and then minor releases will be monthly, right? So we have right now a 1.3 that was just released. 1.4 will come out next month. 2.0 will come out the next quarter. So that's kind of our plan for release cycles. Okay, and then obviously we'll have a compatibility matrix of the different parts of the ecosystem that we're going to integrate into, which is a great segue into the hybrid cloud platform. You may have heard about this. You may have also heard about the GKE on-prem. You know, the thing that we're really focused on as far as the hybrid cloud platform is the hybrid cloud deployment and lifecycle management, right? So we know that there are new roles, DevOps, you know, service designers, you know, people who work on modeling the consumption, all those different roles and different responsibilities, they need to come into a tool or a tool set that they can all relate to, right? So all of their roles are converging, and of course, the environments are expanding and also getting more complex, especially when you talk about integrating those different environments. So the way that I've been describing the hybrid cloud platform is it is a reference architecture, right? So it's very much like FlexPod, if you've heard about FlexPods in the past. It's something that you could build yourself. What we're doing is we are building it, integrating it, and maintaining the compatibility matrix for you, right? So we're developing best practices. What this is a reference architecture that gets validated designs, that gets updated every quarter, that you know, you can either use the validated design to build it out yourself, you know, in a few months, or if you wanted to engage a partner, we've got plenty of partners that have worked with us, and we've also run an EAP, an early access program for this very architecture. So what that means is that, you know, in the past several months, we've placed this architecture, right? So rack and stack and configuration into, you know, data centers for 8 of our strategic partners, right? And then we've had them go through workbook exercises and kind of validate the solution stack as well as the use cases that we're solving, right? So this has already gone through validation cycles. I'd say that we're onto our second phase of the validation, but the reference architecture is going to provide to you a consistent environment and a consistent model for deploying as well as for designing policies and governance for both the enterprise as well as the public cloud. Okay, and then this is one of the customers that we've worked very closely with. So I'm sure that all of you have heard about SAP. You know, they have a heritage in data warehousing on-prem. They were seeing that data definitely was being distributed, especially you know, IoT data or sensor data that was being processed by ML or machine learning or just big data in the cloud, right? So there was a preferential treatment for like customer or sales data that had to exist on-prem. And then, of course, it needed to be integrated with IoT data that existed, of course, on the public cloud, in the public cloud. And so they created this data hub, which basically has kind of a serverless data pipelining, you know, part component to the framework. And then it has a runtime that has to be delivered near where the data is. So that's kind of a short summary of what they were doing with Data Hub. But the reason why they partnered with us is because the Data Hub and then, you know, the framework for the Data Hub needed to run on Kubernetes, right? And so, you know, Kubernetes, the Data Hub itself needed to be on-prem, and we delivered CCP for them to meet this demand. And so you could see that, you know, they chose Kubernetes because one, containers can be pervasive across the different cloud platforms. And that's their approach is, you know, they need interconnectivity between the different cloud targets, right? And they need a way to provide secure transport as well as just connectivity and overall policy for the pods that run. Okay, still time to visit us at the Cisco booth, and then many ways for you to engage with us. I'm going to have time for a demo, so it's very good. And then I don't know if you heard about the Cloud Challenge, right? So if you are a part of a team that needs immediate and impactful results, you can enter into the challenge. Other than bragging rights, right? You can win $25,000 of credits in GCP, which is a grand sum, and then you can get a CCP license for a year. Okay, so I'm going to go into the demo. Okay, so what I'm going to show you first is CCP. And you can see that I've got tenant clusters already deployed. Now, let's make sure. Because I mentioned that there is a VMware component, I'm going to open up VMware and we'll see if we can visualize that for you. But one of the things that is unique to CCP is that we do upgrades, right? So it's automated. You don't have to get in line to it. You basically choose what it is that you want to upgrade, whether it's the control plane itself or the tenant plane, and then we do the automation for it, right? So the reason why I mention upgrades is because all of us who have interacted with Kubernetes knows that when you Kubernetes, kubelet does not suffer an IP change, or it just doesn't. It doesn't suffer through it, right? So if you change the IP, then you'll have issues with your upgrade because the API server won't come up. So the way that we deal with this is to provide a VIP IP, right? So the VIP IP is assigned to an API server, and then the attributes of the existing cluster are going to be retained when you upgrade, right? So we give network administrators and operators the ability to define their own networks and their own pools. Okay, and then I mentioned that we today have integration into VMware. That's our infrastructure provider. We're going to make this compatible with OpenStack and also bare metal in the future. And then as far as Active Directory is concerned, so we assume that our enterprise customers already have an existing authentication provider. So you'll see that this is already authenticated. And then all you need really here is just a distinguished name, and of course it runs over TLS, securely, and then you define which AD groups you want, and then we automatically query those AD groups for the users, and we allow them to log into CCP, right? So probably this is kind of one of those table stakes, but certainly SSO and mutual authentication and just integration into an existing authentication provider is something that is challenging for doing Kubernetes manually and then doing it consistently. Okay, so we'll walk through that three-step process that I was talking about, right? And we actually won't deploy a cluster because I'm going to do it with an API, right? So okay, so here we're basically choosing the attributes of a typical VMware environment. And the thing about the networking layer is that you can choose, let's say, the Contiv CNI, and you can still operate the Contiv CNI cluster inside of an ACI fabric. So there are a lot of choices. It just depends on the underlay and overlay options that you want to choose, right? And then all I'm walking through here is just the different options that you have. right? So we're going to keep this standard. And then the reason for the username is because we'll create the username and inject the key so that when the users want to directly interact with the nodes, it's going to be delivered by an SSH key and not a password. All right, so you get all these options. And then this is basically, that was the 3 screens, and this would be the 4th screen, right? So what I'm describing to you is a reduction of the complicated logic that initially would apply to doing Kubernetes on your own, right? Now, imagine that you can offer this as a service catalog to multiple users. When you do this, obviously, you can apply a governance model around that, right? Okay, so I'm going to go back. And let's say that I want to interact with this cluster, right? So I have the option to upgrade, but I won't upgrade because I don't have the tenant image for that. I'm going to download the token. Okay, so we'll see here. That's the token name, right? Okay, so what I'm going to do is, all right, so basically what I did was, in order for me to interact with my cluster, I have to run kubectl, right? In order for me to run kubectl, I have to define at least a config file, and this is basically that config file, right? So this is the representation of that cluster that I saw in the UI, right? So what I'm showing you is a seamless and easy way for consumers as well as administrators to interact with the assets that they deploy. Okay, so I'll show you that these are all the different namespaces, and if we take a look at this, I may be going through this too quickly, but it's basically the same cluster. That's what I'm proving to you. Every control plane has a Swagger interface, right? So this is kind of the design-first approach to providing a consumable platform, right? So you can look at all the different operations, right? And let's open it up. And if you haven't used Postman before, it's just a tool that allows you to interact with APIs. So I'm going to get a token. I'm going to do a get for the clusters, and then I see all the different clusters. So I'm going to do a create cluster. All right, so hopefully you can see that I'm naming it Google Next 18 TDN. So we do not have a cluster with such name. And now hopefully we'll see that it starts to show up. Right, so it's going to take a while to provision, more time than we have. But the point here is that you can easily interact with it through APIs, right? So one of the things that I wanted to show very quickly, now again, this is the CloudCenter product that is one of the pillars in the hybrid cloud platform, is not a part of CCP, right? So I just want to make it clear that what I'm showing you, CloudCenter, is not a component of CCP, but it'll show you how, it's one thing for a developer or someone to just interact with the cluster using kubectl, right? Very, very difficult for you to apply a governance model around it. I won't let this distract us too much. So basically, what I was going to show you is that CloudCenter is a multi-cloud application delivery and application lifecycle management tool, right? So what I was going to show you is, hey, instead of allowing users to just go to Kubernetes and do a kubectl command to add a new namespace or to delete a namespace or to create Istio or to install the service catalog, you would you would develop these different service catalog items, right? So you would present them in the catalog, and then what you could do is apply kind of an RBAC model to the privileges to those assets, right? So only certain people would be able to do it, right? And of course, because of CloudCenter's agnostic kind of nature, what happens is you only have to develop that service once, right? And then that service conceivably could be executed on any of the environments that CloudCenter supports, right? And if you don't know about CloudCenter, it's quite broad in, it has a very rich integration ecosystem as far as clouds are concerned. All the public clouds that you can think of, as well as many OpenStack variants, and of course we showed VMware.